Okay, so let's get into adding and subtracting rational expressions. This is where some of the, I guess, more challenging things come into play, especially considering, unlike denominators. But first, I guess I'll break this video up into sections. I don't know how long each part's going to be yet, so I'll do like denominators, and then I'll probably stop and then do unlike denominators in a different video, and then maybe complex fractions in a different video. So it'll probably be about an hour in total if I combine the three, but we'll see. So adding and subtracting rational expressions, let's first talk about like denominators. So it's just like adding fractions in general. When you add fractions, you keep the denominator the same and you add the numerators together. So, I mean, I've got an example here, but the one that I always go to is think about 1/2 plus 1/2. If you have 1/2 plus 1/2, half a pizza plus half a pizza, you have 2 halves of pizza, which is, of course, one whole pizza. 2 over 2 makes 1. So notice what I did in this problem and what you do as well. The denominator doesn't change. The denominator is still 2. It's still out of halves. But you're adding 1/2 with 1/2, which makes 2 halves in general. So you're adding the numerators up, but you're not changing the denominator, which is why it's very important that we have a common denominator. So if I want to add 1/5 plus 3/5, it's already got the fifth part. It's got the denominator part, but you add the numerators. So 1 plus 3 makes 4. So if you want to think about, like, I always think of pizza because I'm a hungry person all the time. If there are 5 sections of pizza, right? Let's say you have 1/5 of pizza, right? And you're adding, and you're adding 3. I meant to use a different color. You're adding 3/5 of a pizza. Then altogether, you've got, of course, 4/5 of a pizza. So that's kind of the idea. You have to keep the denominator the same because that's sort of its base. So it's very key to us that we have the common denominator for adding purposes. And subtracting, same thing. So 4/7 minus 3/7, we know the denominator is 7. But 4 minus 3 is 1. So it'd be 1/7. Okay, that's all adding, subtracting fractions are. It's very basic, but it's very, very important we have a common denominator as well. So we're going to deal with common denominators in this video, and we'll deal with unlike denominators in another video. So now let's apply that to our rational expressions. So notice this rational expression. I've got this one plus this one. And notice that they both have a common denominator. They both have x plus 4. So I know the denominator is not going to change. I still have x plus 4, just like I had in those other problems previously, the 5th and 7th problem in the last slide. My denominator is x plus 4. That's not going to change. But now I have to add my numerators. I'm adding x minus 3 with x minus 2. So in this case, all you're doing is like terms. You want to think about it like this: x minus 3 plus x minus 2. You've got x plus x, which is like terms, which makes 2x, and negative 3 minus 2, which makes negative 5. So when you add them up, you get 2x minus 5. And since nothing else cancels out here, nothing factors or cancels, that is as simplified as it gets. That would be your answer, 2x minus 5 over x plus 4. So make sure you add correctly as well. Number 2, very similar. I've got a common denominator, x plus 3, so I'm going to keep that common denominator exactly as it is, x plus 3. But I'm adding my numerators. So again, you're just going to add like terms. So we're going to do, we have 3x. I'll write it out over here. 3x plus 2x is what I'll do because those are like terms. So 3x plus 2x is going to combine to make 5x. And negative 4 plus 5 is going to be positive 1. So 5x plus 1. So there you go. 5x plus 1 over x plus 3 is our final answer. Now, let me point something out. Didn't occur in this problem, but it could occur in other problems. For just theoretically, okay, let's say theoretically my answer was 5x plus 15. Let me try to write this without it screwing up. 5x plus 15 over x plus 3. Let's say that is what I got as my answer. Notice the top can be factored. The top part can be factored by dividing a 5 out and getting an x plus 3 remaining. That top numerator could factor into this, And then, of course, you have the x plus 3 on the bottom, which would cancel it out with that, leaving you with just simply 5. Now, of course, that doesn't happen in this example because it's not plus 15, it's just plus 1. But I'm just pointing it out there because it could occur in other examples, okay, where you would have to factor and cancel stuff out. Now, there's nothing, like I said, in this one that factors and cancels out. So let's try a different one. This is subtraction, so let's pay close attention to that. Of course, it still has a common denominator, so that's the easy part. We already know that common denominator is not going to change, but I am subtracting my like terms up here. So keep in mind that we have 3x minus 4, and we're subtracting 6x, and don't forget we're subtracting 1 as well. So I wrote minus 1 because that's what I'm doing. I'm subtracting 1. So when you combine like terms, you got 3 minus 6, which will be negative 3x. And then you have negative 4 minus 1, which makes negative 5. So please be very careful on your subtracting. That's going to be very, very important. It's very easy to mess that up. But remember, you are subtracting, so you're going to take 3 minus 6 and then negative 4 minus 1. So you have to remember that you're still subtracting a positive 1, subtracting a positive 1, and subtracting a 1. So a lot of people mess that up. So please, like I said, be careful. Okay. Number 4, and I guess just one more, or I guess maybe there's 2 more, but one more for this slide. Again, point out the fact that my common denominator is already 3x minus 1, so I don't have to change that. The hard part is I got to subtract my numerator. So let's look for like terms and we'll subtract. So I got 3x squared minus 2x squared. 3 minus 2 is 1, so that'll leave me with just 1x squared. Notice I don't have, as far as x terms go, this is the only one. But remember, I am subtracting a negative 3x. So by subtracting a negative 3x, that's going to become plus 3x. And you're probably wondering, well, what are you subtracting it from? What's the point of changing the sign if it doesn't combine with anything? Well, technically, you can think that there's 0x term over here, right? There is no x term on the left, so it's 0x. So if you do 0 minus negative 3, well, then you have 0 plus 3. 0 plus 3 is still a positive 3x. So just remember, you're subtracting a negative 3. That turns into a positive 3. We still have one more, though. We still have negative 5 minus negative 2. So negative 5 minus negative 2 becomes negative 5 plus 2. And negative 5 plus 2 would have been negative 3. So there's your numerator. There's your denominator. It's worth checking, but the numerator will not factor here. Again, it's always nice to check to see if you can factor and cancel anything, but nothing here will factor and cancel. So you'll just leave it as it is. That would be your final answer. So let's just do one more. Again, more practice. So again, we have a common denominator. We're not going to change that. It's still x squared plus 7x plus 12. I know in the past we've been factoring and then canceling and simplifying, but when it comes to adding, subtracting, you do not want to factor first. Well, not at least when it already has a common denominator. Your goal for adding, subtracting, your main goal is to make sure you have a common denominator. Now, for all these in the video, all these, of course, have a common denominator. But when we get to the next video, our number one goal is to make sure we have a common denominator. When we have that, we don't want to factor anything out. We don't want to try canceling anything until we've added things together. So how it's going to work, make sure you have a common denominator, then add or subtract, and then factor and cancel. So we have a common denominator. Now we're going to add or subtract, in this case, add. And then we'll see if we can factor and cancel. So I've got 3x plus 4, and I'm adding it with 2x squared plus 6x. So my 2x squared is still going to be 2x squared. My x terms will add up. So 3 and 6 make 9x, and then bring the plus 4 as well. So my numerator would be 2x squared plus 9x plus 4. So I've added the numerators together. I kept my denominator the same. It's worth checking, but let's see if we can factor these and cancel them out. It's worth checking. So the numerator, so let's do that over here. 2x squared plus 9x plus 4. I'm going to factor that using product and sum. So a times c, 2 times 4 is 8, and b is 9. So two numbers that multiply to make 8 and add to 9 would be 8 and 1. Now, a is not 1, right? A is 2, so I cannot use my shortcut here, so I have to do this the long way. So it means take 2x squared, replace the plus 9x with the 8x and 1x with those two numbers, so plus 8x plus 1x. I'll rewrite this as plus 8x plus x. And then at the end, don't forget the plus 4 at the end. So remember, you're just changing this middle term with the 2 from here. And then you factor by grouping. So the first group has a 2x in common. That's GCF, so this would be 2x. And then x plus 4. And then the second group already is x plus 4, so we're not going to change that. So the factors would be x plus 4, because that's the common factor, and then 2x plus 1 is the other, so 2x plus 1. So that's the numerator. So x plus 4 and 2x plus 1. Now let's factor the denominator. Denominator will be a little bit quicker because we can use the shortcut with it. So let's see if I can erase all that. So at the bottom, x squared plus 7x plus 12. Product and sum, two numbers that multiply to 12 and add a 7. This would be 3 and 4. So this would be x plus 3 is a factor and x plus 4 is a factor. I feel like I did this wrong earlier today when I taught it in my honors class, because these x plus 4s cancel. I don't remember if that happened earlier. So we have 2x plus 1 over x plus 3 as a final answer. All right. So that is that. Make sure you have a common denominator, which all of these did. Add the numerators together. Make sure you combine like terms is all you have to do, and then factor and cancel like we've done in the past. And that's pretty much all you have to worry about. So in the next video, we'll do unlike denominators. I'll see you then.